Today we will talk about the QC and KC, basically. QC and KC, like what are these both terms? Basically, like when there is equilibrium, for example, A plus B, there is equilibrium C plus D, right? So here the expression will be written in KC, which will be C D upon A, according to law of mass action, which we have already studied in my previous video, right? But what is now QC, right? We obtain KC when there is equilibrium state, when there is a state of equilibrium, right? But what about QC? Like QC is a value, is a constant, basically a value. It is a value which we get before the equilibrium, For example, I have a reaction A plus B plus C plus D. Here the equilibrium is not there, right? And like obviously it will take some time in order to come to that equilibrium point. So before that equilibrium point, the value is known as QC, and at the equilibrium point the value is known as KC. Now let us understand that how to write the expressions and the units for Kp and Kc for the reactions. Like I also discussed about Kp when we are having the, for example, concentration in basically in terms of pressure, right? So that is known as Kp. So let's write the expressions for that. For example, I have a reaction which is calcium carbonate, calcium oxide plus carbon dioxide. Calcium carbonate is solid, calcium oxide is also solid, and carbon dioxide is a gas. So now let's find out what will the Kc basically. So what you are thinking right now is Kc is equal to calcium oxide, active mass of carbon dioxide, active mass of calcium carbonate. So if you are thinking this, then you are definitely wrong. This is wrong. Now what will the Kc? Kc here will be equal to only this. Now you will be wondering that why only this is a correct Kc and this is wrong. Basically, during a like when we write Kc, the concentration, or like you should take a note over here, the active mass of the active mass of solid is constant. The active mass of solid is constant and is taken as unity, which is 1. Basically before the reaction we know that there are a lot of molecules of solid before the reaction and also after the reaction, so there's no such changes in the concentration. So that's why the active mass of solid is taken constant and it is taken 1 or unity in the equilibrium. So that's why we know here calcium oxide is also solid and calcium carbonate is also solid. So where we will not put these both values, we will only put carbon dioxide because it is a gas, it is not solid. Obviously before there will be some other, there will be another concentration of gas, and after the equilibrium or at the equilibrium the concentration will obviously change. So that's why. So let us take another example where we have, and so now let's look at what will be the Kp of this. Kp will be basically PCO2 right? This will be the Kp. Now consider we have a reaction which is N2O4 2NO2. This is also in gaseous state and this is also in gaseous state. What will be the Kc over here? So the Kc over here will be, Kc is equal to NO2 to N2O4. This will be the Kc, right? Now let us discuss about for example, we have H2O, which is in basically liquid form, changes into it changes into H2O, which is in gaseous form. Now you will be wondering what it says. When something, like when a substance changes its state, like as you can see here, the water is in liquid, now it is in gas. So basically there is a change in physical state, like in physical state. So that equilibrium is not known as chemical equilibrium. That equilibrium is known as physical equilibrium. That equilibrium is known as basically physical equilibrium, right? So over here, okay, you have to remember, like, what now you'll be wondering that what is now Kc. Kc, if you are wondering this, like Kc will be H2O upon H2O, so then you are definitely wrong. This is not the Kc. The correct Kc will be only this. Now you will be wondering why. Because okay, there is another note, right? Note this thing, the active mass, which is taken in basically in these square brackets, the active mass of liquid with a gas on equilibrium, in equilibrium, is taken unity, is taken as unity, right? So over here we know that this is liquid form, right? This is liquid, so we will not write this, we will only write the gaseous one. So I hope this is clear to you. Then we have another reaction where we have copper ions and we have basically the silver ions, right? Consider that we are having copper plus Ag, which is 2 plus so this is in solid, this is in aqueous, this is also in aqueous, and this is in solid, right? So now what will be its Kc? Now you know the rule number 1. So here Kc will be basically copper plus 2 and this Ag 2. This will be basically the Kc, right? So now let's look at the Kp. So basically here the Kp is not defined. Why? Because we don't have any substance in gaseous form. That's why the Kp is not defined, because no gaseous state, there is no such gaseous state in this, right? Okay, if let's look into this another equation, which is, for example, CH3COOH, which is in aqueous form, plus H2O, which is in liquid form, CH3COO minus plus H2O, which is in aqueous, and this is also in aqueous form. Now you will be wondering what will be its Kc. Its Kc will be, according to you guys, it will be CH3CO negative and H2O upon CH3COOH H2O. So this is basically wrong. Now why? Basically, as you can see over here, we have this aqueous, liquids, aqueous and aqueous. So here liquid is water. It means, like, you have to take a note and write, when the reaction is basically if reaction is in aqueous medium, or you can say in aqueous medium, so there the concentration of water is basically constant. The concentration of the water will be constant, because here the water is a liquid, so it means it is basically the medium where the reaction is occurring, like it is a solvent. So if you will change the concentration of solvent, how the reaction will occur? So this is obviously, the concentration of water can't be changed, right? If you will change the concentration, how the reaction will form? Obviously, so that's why we don't put. So here the Kc will be equal to basically CH3 COO negative, and here H2O because it was in aqueous form. But here we will put only CH3 COOH, which is basically the acetic acid, because that one, this one water is in liquid form. It is basically solvent. It is solvent in the reaction, so we can't change it. So this will be the Kc. If we talk about Kp, so Kp is basically not defined. The Kp is not defined. Why? Because we don't have anything in gaseous form. We all have in liquid and aqueous. So I hope these three notes are clear to you. If the reaction is an aqueous medium, then the active concentration of water will be constant, and the active mass or the concentration of liquid will be constant with a gas, and the active mass of solid will be taken as a unit T, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. We're very glad to answer you guys.